To understand epicyclic gear trains, we start with an ordinary gear train. Now we are looking at an ordinary gear train. It has 3 gears. The green gear is the input gear. It's dia 50. Then we have the output gear, the orange colored gear. That is dia 100. And there is a small idler gear in between, dia 25. It transmits power from the input gear to the output gear. Omega means rotational speed. Now we take a closer look at the idler gear. In the ordinary drivetrain, the gear can and does rotate, but its axis of rotation is permanently fixed. The drive ratio for this ordinary gear train is such that when the green input gear completes 1 revolution in the clockwise direction, the orange output gear turns half a revolution in the counterclockwise direction. Now imagine a design change request comes in that asks for the original drive ratio of -1/2 to be changed to -1/4. In plain speak, for the same input, i.e. dia 50 input gear, turning at the same speed, can we make the output gear to turn even slower, at 1/4 the speed of the input gear? The most obvious solution is to increase the size of the output gear, the orange gear. Obviously, the idler gear diameter will also increase. Note that in this ordinary gear train, only the input dia and the output dia matter. The idler gear dia does not matter, because there are no compound gears in this ordinary gear train. And the mission was to slow down the orange output gear to 1/4 the speed of the green dia 50 input gear. Dia 50 input gear in the revised gear train looks smaller than the dia 50 gear in the original gear train. This is just an optical illusion. But the question is, what if we did not want to change the size of any of the gears? So earlier we said that we would keep the input gear, the green gear, the same size and same speed. But now the new challenge is to actually keep all the gear sizes the same. Because changing the size of gears every time we need a new gear ratio may not be practical. The new challenge is how to change the drive ratio without changing the size of any of the three original gears. The three original gears are the dia 50 green input gear, dia 100 orange output gear, and the dia 25 yellow idler gear. So this is the fundamental question we were talking about. So we have to keep all three gears the same. The dia 50 input gear, idler gear, dia 25, and the output gear, dia 100. And it turns out that the answer lies in transforming our drivetrain, a simple drivetrain, into an epicyclic one. So that's what we will do. As we shall see later, going from ordinary to epicyclic is all about giving more freedom of motion to the idler gear. meaning that in the epicyclic gear train, because of its added freedom of motion, we will start calling it the planet gear. So I'm doing all my modeling in Onshape. It's a great online CAD tool. I highly recommend it. The motor just means that we will have control over the speed and direction of rotation, clockwise or anti-clockwise, of the arm, and by association, the rotation and direction of the planet gear. And we have to keep in mind that the planet gear used to be the idler gear in the ordinary drivetrain we started with. We call the sun gear the input gear in the ordinary drivetrain we started with. In the epicyclic gear train, we will call it the sun gear. And this is just convention. And adding a motor just means we will have full control over the speed and direction of rotation of the sun gear. The motor is just symbolic, and in real life it would be any other possible source of motive power.
Here in the Epicyclic, we note that we still have the original 3 gears. The biggest difference is that the gear that now goes by the name Planet has acquired the ability to orbit the Sun gear, and the part called the arm acts as its carrier.
So this is where we have imbued our ordinary drivetrain with a second degree of freedom, thereby making it an epicyclic gear train. And because of this additional control, the epicyclic is aptly called a 2DOF mechanism. By input speed, we mean the speed of the original Dia 50 input gear, which is now called Sun gear in the epicyclic. The 1/6 RPM value for the arm speed comes from calculations not shown here. I will do a separate video for that. For now, take it to be true. We will cover that in a separate video. Very important to note that now that we have an epicyclic on our hands, for the desired output, the Sun gear input speed alone is no longer enough. Arm speed also needs to be set to a calculated value. So what must be blindly obvious by now is that by going from ordinary to epicyclic, we have gone from a 1 degree of freedom mechanism to a 2 degree of freedom mechanism, which is why we have the original input gear, the Dia 51. It's still there. We will keep it at the same RPM. But now we have an additional input to make, which is the speed of the arm. In both the gear trains, the green Dia 50 rotates at the same speed of, say, 1 RPM. In the ordinary gear train, the orange output gear makes half a turn. On the epicyclic side, the same output gear makes 1/4 turn only. All this due to the newly acquired ability of the Planet gear to walk around the Sun gear. It's the same animation except that I'm letting the Sun gear do 4 complete revs so that we can observe and absorb the motion of all 3 gears as well as the motion of the arm. I've added quadrant marks on all 3 gears. There's tiny triangles in some instances. These marks make it easy to see that there is no sliding motion occurring between any of the 3 gears, which is exactly how it should be. And when I said eagle brained, I was just pulling your leg.